Hey friends, it's Mrs. McBride. I'm sorry I can't be there today. What you're going to do today is something called the coffee filter lab. The goal of this lab is to determine how the resistive force of air resistance relates to the terminal velocity of a coffee filter in freefall. Okay, so what this basically explains is if an object of mass m falls under the influence of gravity, then you get an equation that looks like this. And this should look something like what we were talking about yesterday in class, where we've got mg, the force of gravity, minus the drag force is equal to ma. Okay? This is saying that the drag force in this case is following this equation. B, that's the constant, times v to the something n power. Okay? If we're thinking that they're going to hit terminal velocity, then we can set these two things equal to each other. Okay, in this lab, the mass m will be comprised of coffee filters. So basically what you're going to do is you're going to stand up on your table and you are going to drop coffee filters from the ceiling and time how long it takes them to hit the floor. Okay, so the mass in this case is really just the number of coffee filters times the mass of one coffee filter. And again, if this doesn't make sense, all of that is written there. Okay, so by substituting this in up here, you can get a relationship that looks like this, or basically the number of coffee filters times the mass of one coffee filter times little g is equal to this drag coefficient times the terminal velocity to the n power. Okay? Or we can say that n, the number of coffee filters, is proportional, that's what this little guy here means, to the terminal velocity to the n power. Our goal in this lab is to find n for the drag force. So first what I want you to do is answer these two questions. Okay, so you're going to answer the two preliminary questions. Once you've answered the two preliminary questions, you're going to take some data. So for each set of coffee filters, you're going to take 5 time trials, then take the average. Okay, we only need to take data for up to 5 coffee filters. So you're going to have this being 1, 2, 3, 4, and 5, okay? And whatever your fall distance, this is going to be the height of the classroom, okay? So measure that with the 2-meter stick or with the meter stick, okay? So you're gonna drop one coffee filter, record the time. Drop the same coffee filter, record the time. Drop the same coffee filter, record the time. Fine. Drop again, take the average. Okay? You should know that velocity is equal to distance over time. Okay? So what I want you to do first is that, and then hopefully you'll watch the second video when you're ready to do the analysis part. Okay? Have fun. I'll see you in a bit.